Hello, welcome to this channel. This is Vale, and in this video today I'm going to be sharing something very interesting on reverse engineering. Now you know that I'm learning reverse engineering and exploit writing myself, and when I am practicing my stuffs and if I feel that something is worth sharing, I instantly make a video on YouTube for you. So in future I can keep this for myself as a self-documentation, and on the other hand you can learn something in the process. So in this video today I actually downloaded a program from GitHub which is a basic C program about asking the user for a username and password, and if the given username and password is correct, then I get access to the program with user privileges, and if I can manage to give the root username and password, then I get to go and log in to the admin section of the program. Now the program itself has nothing important, so whether I log in as a user or an admin, I can't actually do anything with that. But the objective of my tutorial today is to see that if I can reverse engineer the program and gain access to either of the admin or user accounts without knowing the username and password for any of those accounts. So I'm going to jump into my Kali VMware or Kali virtual machine in this case, and then I'm going to install GDB, which I have already installed it, and I will show you how to install GDB as well, no issues. So GDB is a command line disassembly program that comes in Linux. So now doing the same things with dedicated reverse engineering tools like IDA Pro or Ghidra is actually better and it's easier to understand, but I am specifically choosing GDB only on one reason, and that is these things are not actually pretty easy to label. So when I'm doing these things, you can actually see for yourself hands-on that what is exactly happening under the hood. So what I'm going to exactly show here is all in assembly language. So what happens is when a program is being compiled, the instructions are converted or compiled to basic assembly language, which in turn gets compiled into the simple binary numbers and gets executed from the CPU. Now doing the same things with the direct binary is pretty hard, so we use assembly language. Now I have uploaded this video about stack frames a couple of days ago on YouTube on this channel, and which explains only about what happens in the stack. So now that doesn't exactly cover all the basics of assembly, but it covers a lot of it. So I suggest that you first learn some assembly, some basic assembly from anywhere you want, then come to the previous video that I uploaded about stack frames, and then come to this video. So if you already know stuff about stack frames and basic assembly, then you can watch this video, it's fine. So this video is not something too much important, but it's fairly interesting. So that's why I'm going to do this video, and in the process you can learn the basic mindset for reverse engineering. So here I go. I will just directly jump into my Kali virtual machine and reverse engineer this piece of code. So if I just open it up, here you can see my program. This is actually not my program, I downloaded it from GitHub. So I will be explaining the code in a few moments. So I'm going to cut myself off from the main screen and directly dive into today's video. Okay, so let's start with reading the code and what it means. So I'm going to just open up the program, and as you can see that this is a very simple C program, and the job it does is it introduces three functions, and the functions are written like this. So I'm taking two variables for username and password. They are all character variables, and the space that they will be taking on the memory is 16 bytes, so as character takes 1 byte per character anyways. So I'm going to print the username and print the password that I have just given in. I'm going to scan or take the input and password from the user and then compare it. So if the username is user1 and the password is password, then I'm going to return 1, else if the username is admin and the password is @dm1n, in that case I will return 0, or else I return -1. So there is the second function, which is a void user menu. Its only job is to open the user menu, and for the same thing that is done in admin menu, so I'm going to just print opening the menu, and this is a super secret message and whatever. So in the main function, what I'm doing is I'm taking an integer variable and then calling the authenticate user function, which will take the username and password. Now if the ID is greater than -1, so it's checking first that if the ID is greater than -1 or not. So if it is greater than -1, this part of code will be executed, else this part will be executed, which is authentication failed. Now if this part was a success, then it will again branch out where I can see that the code is, if the ID is returned 0, then we are going to open admin menu, else we are going to open user menu and then return 0, which means basically the program is ending right here. So let's pretend that we didn't see the code and we do not know the username and password, whatever it is. So let me just scramble it without looking, whatever it is. So specifically I'm not looking, so the password is maybe whatever, then the admin, and again whatever. So I do not know the password definitely, so I'm going to save the program. I'm just going to check if there is a bad character or illegal character right there. So no, there is no illegal character. Okay, so now I'm just going to open up my terminal and write okay, so first let's move on to desktop. Okay, and then I'm just going to write gcc output the file with the name rev, and the input file would be reveng.c. So I think the program has been compiled, and let's just check the program. So nice. So it is asking for me to give a username, so I don't know the username, and if you have noticed that they are all gibberish letters that I have typed in without looking. So let me just type in hello, and the password being pass, and the authentication is failed. So I don't know the password or the username in this case. So let me just try and disassemble this program. Now to install GDB, or the command line interface for disassembly, is going to be sudo apt-get install GDB. As simple as that. So I'm just going to give the root password, and then it's going to be installed. Okay, did I just forget the password for root? What? Yeah. So as you can see, GDB is already installed to the newest version. So as my GDB is actually installed, that's why it's not installing a new version, but in your case it will. So now let's just start GDB. Alright, so the command to run GDB with our program here is to just say, okay, just let me go back to desktop because the program is in desktop. Okay, so now GDB rev, because rev is the name of our executable file. So I'm just gonna hit enter. Okay, so I just want you to remember the commands, or write it down, or open up a cheat sheet on Google about GDB, because believe me, remembering the commands is not as important as figuring out the mentality or figuring out the mindset of how reverse engineering should be done. So what I'm going to teach here is how the reverse engineering mindset should be when you are actually performing a reverse engineering. So the commands is not important. If you do it 2 or 3 times, you will remember it without a problem. So just remember the commands, or write it down, or open up a cheat sheet. It's not important. So the first thing that I'm going to do is debug the main function, or disassemble the main function. Okay, so let's start with disassemble main. Okay, so it's a spelling mistake, I see. Disassemble main. Right, so you can see the assembly version of my C program is like this. Now as I can see that this is an AT&T syntax, so what I'm going to do is convert this syntax to intels. So for doing that, the command is set disassembly flavor intel. Okay, intel, and again I'm going to disassemble main, and now you can see that all the instructions and the version of assembly, or the syntax of assembly, is in now of Intel flavor. Right, so now the most important thing when reverse engineering is to figure out what the code means. Now I have already shown you the actual code behind this program, but let's just pretend that we didn't see the code and we have to manually figure out what the code means. So what I'm going to do is first open up a piece of paper or a piece of notepad software. So in this case I'm just going to use mousepad. That is a default one that comes with Kali Linux now. So I am going to take notes by reading these instructions of what's going to happen. Now you can probably familiarize yourself with these instructions if you have already seen my previous video about stack frames, or if you know about stack frames, or you have been exposed to assembly before this, so you can already familiarize with all of these instructions here. But believe me, all of these instructions are not very important, because the main things that we are concerned about is the main calls or compare. Okay, what did just happen? Let me do this thing again. Okay, so I think there was an illegal copy or paste command that I have given. So disassemble. Okay, so now as you can see, that main instructions that we are going to be taking note of are the call instructions, the compare instructions, the jump instructions, the call instructions. So these things will give us a pretty fair idea about what each of the instructions does. All right, so let's start with this call function, because as you can already understand that these three lines basically make up the space in stack frame. So these things I'm not going to be telling in very detail with, because that has been already done in my previous video, and this is not important for this today's particular tutorial about reverse engineering. So let's first see what this call does. So the first call will be called from the memory address 1172, right? Okay, 1172. Now what this does is it calls some function called authenticate user. All right, and this specifically calls 11b6. So is there a 11b6 right here? Okay, not exactly in here, which basically tells us that this function's address is not exactly here, but maybe from the next section, which is not disassembled because we are just disassembling main. So I'm just going to leave it at that. So calls a function. Okay, so 1172 calls a function, something called authenticate user. No problem. Now the next thing we are interested in is this compare function. So it is at 117a. So I'm just going to write 117a compares something. Then we are just going to take note of the JS. Now JS is a specifical jump, but the S specifically means sign. So it reads as jump if sign. So in this case, what we actually want is that if any of the status flags is set to a signed integer, which means it's a negative integer, then jump. Okay, so I'm just going to say that at instruction 117e we have jump if signed to where? To 11a3. So let's find out where 11a3 is. Here. So 11a3. Alright. Now the job for 11a3 is at LEA, or load effective address. There is a load effective address instruction, which in this case specifically means it's going to go to this address and copy the value in RDI, or in this case the destination index. So what I am thinking that this might be some string which is stored in the memory, and that is being called by this instruction, and the instruction is puts. So I guess that these two lines specifically mean that there is some print or display something in the screen, something like that is happening. So we are not interested in this. So we can actually say that 117a compares something. So if signed, then it jumps to 11a3 followed by a 11AA which prints something, right? All right. Okay, so this compare function compares something, and if the result is a signed integer, then we are jumping to 1183. So what if it's not a signed integer? In that case, I am performing another compare instruction. So let me just try. On the next line, that is 1180. So if signed is that answer, so which means if not signed, then it's going to move to compare. So the instruction address is 1180. So 1180 compare. Again, it compares something, and then if jump not equal, so it's now comparing that if those two values are exactly equal. So in that case, if the values are not equal, then it is going to jump. Okay, so compare something, nice. Then on line 1184, if not equal, jump to 1192. So where is 1192? Here it is. So in 1192 we are not interested in this particular line, but followed by the next call instruction. So then it calls the user menu. So jumps to 1192 followed by 1197, which specifically calls the user menu, right? So in this case, if equal, then it would have jumped to, let's see, so user menu, so jump, okay, so jump if not equal to 1192, else again 1186 is executed. So 1186, which is not important, followed by 118b, another move, another call instruction. So 118b, which is a call instruction, and it calls to admin menu. So let me just put it in the right syntax. Okay, so it's now calling admin menu, which is at 118b, right? Then jump to 119c. Now what is at 119c? So 119c is followed by move, and that is followed by jump 11b4, and at 11b4 we have the program exit. So I think I have covered the whole program here and analyzed the code, which can basically mean this. So again, if I just read this part now, at 1172 instruction, it calls a function called authUser, then 117a compares something. Am I right? Yes, 117a compares something. Then 117e, it checks if the compare result is signed. It jumps to 1183 followed by 11aa. So 1183, 11aa, and it prints something. All right. If not signed, it jumps to 1180, which again compares something. So if the comparison is not equal, then it jumps to 1192, or in this case, which is user menu. Or if it was equal, then it would have jumped to admin menu, 118b. Alright, so I think I have figured out the program, and what I need is basically break something here. So let me first run this program and check what it exactly means. So if I run the program, first it is asking for the username. So I can say from here that this one's username. So let me just type in any username, then again the password. So the authentic user function is doing the same thing as taking username and password. So I'm also going to give a password, whatever it is, I don't care. Then authentication failed. So let me just check. It compares something, I still don't know what. If signed, then it jumps to print something, and if it is not signed, then it's going to user or admin menu. So I can see that I am not being redirected into any of the user menu or the admin menu, which specifically means that this comparison function was actually signed. So I went directly to print something. Alright, so I can pretty much be sure that this print something is basically authentication failed. So let's check it in the right way. So I'm just going to set a breakpoint at the main instruction. So break main, and now I'm just going to execute each instruction one by one. So next instruction, enter. So let's start. Next instruction is at 516D. I don't know what 516D is. Okay, I guess that these numbers have changed. So let me just go and disassemble this again. Okay, so you can see that these have changed to 5. So 1156, 1165 became 5165, 1166 became 5166. So I'm just going to turn all of these to 5, just to be precise. Nice. So you can see that I am currently sitting at this instruction. So let's go ahead and execute the next instruction. So on the next instruction, I'm at 5172. So I'm at 5172, and let's see what it does. So 5172 is asking for a username and password. So the username is whatever, the password is whatever. And on the 5177, so do I know what 5177 is? Not yet, no problem. Just I'm going to check the next one, 517A. So I am now at 517A, which is compare something. You can see 517A, 517A. So on the next instruction, I'm just going to go for 517E. So 517E is just checking that if the result of the compare function is a signed integer or not. So the next instruction will tell us a lot about what exactly happened. On the next instruction, I'm going for 5183. Now, what is 5183? Look, 5183 is right here, jumps to 5183 followed by 51AA, that is basically print something. So I am guessing that it will be authentication failed because I didn't get jumped to any of these but directly to these. Okay, so 5183. So on the next instruction, I'm going to 51AA. So you can see 5183 followed by 51AA, and on the next, authentication failed. So I can be pretty much sure that these two lines specifically means that if the number is a signed integer, then it's going to be authentication failed, and if it's not signed, we will be going to this section. Okay, so just let's check the registers now. So what I can specifically do in GDB is when I am doing each of these instructions one by one, I can see the registers and the CPU registers and their flags and their statuses one by one each time each of these instructions get executed, and see the state of the registers at that point. So for example, if the EAX's value was 10 in this instruction, I could see the statuses of the registers, and in EAX I would find 10. If on the next instruction the EAX has been updated to 20, then if I see the registers, I will see EAX as 20. So I'm just going to run the program again. Yes, I'm starting from the beginning, and this time check the registers instruction by instruction at each point, and I'm again going to see these instructions to see what exactly at and what line what register is changing and what registers we actually want to edit or see to bypass the login process. So if I reread the code again, I'm just going to do it from here. So I'm just going to write again disassembly main. So you can see that just before, where is the compare function? Right here. So just before we compare the function, which I can see that the compare function is doing two things here. It's first taking the value from the memory address. Listen to me when I say this function, this instruction is taking the value from the memory address, which is base pointer -4, and comparing it to 0. We can also see that on the previous line, this move operation is doing the same thing. That is, it is copying to the memory address, which is the same as this one, that is base pointer -4, and in this memory address, it is keeping the value of EAX. Now I can be pretty much sure of one thing, that whatever authenticate user function did, for example, if you can remember from the program that I showed you, that in the authenticate user function, what the programmer did was he took an input for the username, an input for the password, and then set the return numbers specifically for admin menu, for user menu, and when the password matches none. So you can be pretty much sure that whatever authenticate user function returned was kept in the EAX register, and on this particular line we are moving the value from that EAX register to the memory address base pointer -4. And on this next instruction we are just comparing the value that is just being copied from EAX to the memory address with the value 0. So if I study what is within this EAX register, we can be pretty sure that this memory address, or this, which is basically the same, has the same value which EAX had and which authenticate user function gave to EAX to carry on. So what I'm seeing here specifically is that if the compare function is done correctly and if the result is not a signed integer, then only we are getting to this section of whether we give a user level username and password or an admin level username or password. In this case we are directly getting authentication failed, which means that we somehow have to make this EAX, in this case this memory address, which will be carrying the value which was in EAX right before the function 117a happens. So if we are able to change the value of this memory address to something that is not signed, then we can get into this section, or else we are still going to get authorization failed. Alright, so let's test that out if it's correct. So I am just again going to run the program again and go on instruction by instruction. So just tell me when I'm coming to the compare function. So username is AAA, whatever it is, I don't care. Password is whatever it is, I don't care. 5177, we are at 5177. Then 517A comes in. So let me check which instruction I'm exactly executing right now. So if I just go disassemble main, I can see that I am particularly executing this instruction right now, which means this instruction has just been done with. Alright? Okay, so I cannot change anything for this instruction now. So what I have to do is go back to this instruction for EAX being a non-signed integer. In that case, what I'm going to do is I'm going to run this program again, start it from the beginning, so I can remember the address, which is 5177 is the address where the EAX's value is copied to this memory address. So I'm going to stop at that address. So particularly I'm just going to go on instruction by instruction. So whatever, I don't care. So I'm at 5177, which is this function. This instruction is going to be executed right now. So whatever value is in EAX, in this instruction, it comes from EAX to this memory address. So if I have to do anything, if I have to intercept that from happening, what I have to do is change the value of EAX. So when I go to the next instruction, the value of EAX which we edit is going to be copied to this memory address. So let's just do this and say info registers. So I have all the registers right here, and to view what is in a register, the command is simple as print EAX. So if I just print EAX, you can see that the current value of EAX is -1, which is basically a signed integer. And in this, and this is the reason why, if it was signed, which is in this case it is signed, so it was jumping to authorization failed. So what I'm going to do is change this value to 0 and see what happens. So I'm just going to say set EAX to 0, and let me check if I succeeded. So print $EAX. If I do that, I can see that the value of EAX now is currently 0. So I'm going to run the next instruction and see what happens. On the next instruction, which is 517A, so if I just go disassemble main, I can see that it's now comparing the functions. So EAX, I just edited this EAX's value from -1 to 0. So this memory address is now specifically holding 0, and on the comparison function is specifically going to do if 0 is equal to 0 or not. So I'm pretty much sure 0 is equal to 0. So what happens if I go on the next instruction? So you can see 5170 is supposed to jump, and on the next instruction we should have gone to 5183 because I don't know the password. No, I don't know the username and password, so it should go to authorization failed, but I can see that the next instruction that was executed was 5180, which means I am in this section of the code. So let's see what happens on the next instruction. Now it's going to 5184. So if not equal to what, I don't know, because I cannot see everything from here, because for what happens in user menu and what happens in admin menu, I have to disassemble those functions as well. So what I just know is that from the code that was originally written on the C file was that in the function authenticate user, if the username and password that the user provides is a user level username and password, then the value would be return 1. If it was an admin level username and password, then it will return 0, and if none of those matched, then it would have returned -1. So we exactly saw that what it was returning was -1, and that's why we were getting authorization failed. So what I remember from the previous program was that when the value was 0, I should go to the admin menu. So if I just press next instruction again, I'm at 5186. So if equal to, so you can see that I'm already at the address 5186, which will be followed by 518b, and which is specifically going to call admin menu. So on the next instruction, we are going 518b. So the next possible instruction is to call admin menu. So ni, and I am in the admin menu. So opening the admin menu, this is the secret message. So you can see that I am in the admin section of the program. Now this program is not important, but just assume that this was a serious program and the admin panel has something really serious in there. So I have just hacked my program into getting into the admin login of the program. So neither we did figure out what was the password for user, neither we figured out username and password for the admin section. What I just simply did was whatever authenticate user function was returning as a value of 0, 1 or -1, we just intercepted the return value of authenticate user and led my program to think that I am actually an admin user trying to get in the program. Okay, this is a bonus content and I'm not going to explain everything I do here because just in the previous lesson I have explained almost all of it. So I'm not going to break or bypass the login process, but I actually want to know what the username and password is for any of those admin or user menus. So let's try and do that. So we already know that authenticate user is the function that does the username and password comparisons for us. So let's disassemble this function now. Okay, so you can see I have disassembled the authenticate user function, and I can pretty much say that print there is a print function here, so maybe it wants us to give the username, then it takes the username from our keyboard, again it prints the enter password section, and then again it takes the password from the keyboard. What we are interested in is this compare function. So just before it uses the compare function, I can see that the strings are sent to the compare function via the RDI and the RSI registers. So if I somehow stop at this instruction, then I can read the current values that is within RX and RSI, and as you can see there is a load effective address instruction, which means that whatever it is in this memory address and this memory address, the exact address is computed and has been saved to RAX and RSI, which means if the address within RSI and RAX and RSI has the original strings for the username and password, we can pretty much gather that information. So let's first take note of this instruction or this line here, that is 121B. So if I can stop at this instruction, maybe I can read what is at RAX and RSI. So let's just go to this line. So first I'm going to set break at authenticate user, and then I'm just going to set run, and next instruction I'm going to stop at what line? Let me just check again. I'm going to stop at 121B, no problem. So in this case it's 521B because the instruction line numbers or the addresses that it is going to fetch the instructions from has just been changed. So the address I'm looking for is 521B. Let me check again. Yes, it is going to be 521B, not 121B. So it wants the username, whatever it is. Okay, let me just give it something that we can understand. For the password, I can say pass 5214 521B. So I'm at this line, so you can see if I just say disassemble authenticate user, you can see that I am now currently executing this instruction or this particular memory address 521B. So if I have to see what is in RAX and RSI, these are the two registers that we are mainly interested in. So if I just say info registers, I can see in RAX we have something. So this is the memory address that LEA has computed for us. So if I wanted to see what is in this memory address, I can just print the ASCII that remains at that memory address. So for the syntax is x/s and this address. So I can see that this is the string that I typed in for the username. So if this is the one that I typed, then the RSI will probably have the original username that was hard-coded in the program. So if I just copy and do the same thing for RSI, okay, so this is one of the usernames. I can pretty much say that I have to copy this and paste here. So let me go on this compare instruction. Okay, so I can see that after it actually compares the string, it tests for something. This is specifically a AND operation, which says us that if the resulting answer is a 0 or not. So if that jump is not equal, then it's going to jump to 5245. So where is 5245? This is 5245. And what I actually know from the previous program, that it checks the username and password at the same line, and if those two doesn't match, then it checks the username and password for another user on the second line. So which means that in here we just check the username, which didn't match, so it didn't execute these instructions for the password, but it directly moved on to 5245, which is it's now checking the username and password for the admin user or the normal user. So I'm not sure which user it is, but I can pretty much say that because this username didn't match, it didn't even check for the password, but it skipped to check the username and password for the second user. So what I am going to do is I'm going to step over this line here and manually change the value of EAX to let the program think that I have given the right username. So the line is, I can see 5223. So if I just go and type in next instruction, and I'm going to stop at 5223. So now if I just do info registers, I can see that we do not have an EAX right now. So if I just say print EAX, I can see the value is 10. Alright, so let me just try with 0. Set EAX to 0. So at this point, let's see what happens. 5225. Now it's going to 5227. So what is at 5227 now? Okay, so as you can see, this comment was at jump not equals. So I have somehow made the comparison equal here. So that's why it didn't go to or didn't skip to 5245, but started executing from the next lines. That is right here. So again, there is a string compare, and I'm guessing that this is the password check because the username check has just been done. It was wrong. The EAX's value was not there, so I manually intercepted the EAX's value to be 0. So it moved on to the next lines, and here is another string compare, which I guess is the check for the password. So if I again stop at this line, I can read whatever it is at RAX and RSI. So what is this line? 5232. So I'm going to stop at that line now. Again, next instruction. Now we are at 5232. I'll just let you see by yourself. So disassemble authenticate user. So you can see that currently I am at this line. So I'm going to read the values from RAX and RSI. Again, that is a LEA instruction, which means that RAX and RSI will have a memory address, and we will have to read whatever is it at that memory address. So if I go in for registers, RAX and RSI are the registers that we are interested in. So let me just copy the value from RAX, which is a memory address, and just say print, SXS, and instruction. I can see that this is the password that I personally gave, so this is not the one, and this is being compared to whatever it is at RSI. So if I copy this, I guess I will get the actual password that was given in. So if I just say XS this memory address, I can see that this is another something that I get. So if I copy that and paste here, and now let me close the debugger and normally run the program saying cd desktop and rev. Let me give the username as this one and check, and the password being this one. Authentication failed. Why? I don't know. Okay, sorry, those two are the same thing, so I probably mistaken to copy something. So again, I'm going to run this. I'm going to copy this, paste, copy this, paste. What? Authentication failed? What? I don't know. So is the reverse the right one? Let me see. Okay, you can see there is a segmentation faults that happening, which specifically means that if you can remember here, we only had space for 16 characters, so there is a buffer overflow that is happening right there, so that's why it's giving me a segmentation fault, and these are more than 16 characters. So I'm not going to change the password here and debug or disassemble again, so I'm just going to change this to maybe 32. Why not? Or whatever it is. So let me just save this, recompile this, and let's see what happens. So so now let me run rev, and as the username I will just give the first one and the second one. I'm thinking that it won't give me a segmentation fault. See, opening the user menu. So what I did was find out the user menu, not the admin menu. So if you can try, then you can also get the actual username and password that was hard-coded for the admin user by the same way, because if you remember, I just used the first two string compares and intercepted the username and password for the first two string compares. So I gathered that if the last two string compares we did the same thing for, then we would have gotten the admin menu passwords. So I'm going to end this video right here. There is a lot of things that is still remaining for me to understand and for me to teach. So if you subscribe, if you like this video, if you let me know why and where you used these things, so then I will be very happy myself. So I'm going to end this video right here. I think you have learned something from it. See you next time. Goodbye.